Hi, this is Mrs. Phelps. If you're just tuning into my math notes, what's up? How's it going? And if you're coming back, what's up? How's it going? It's really good to teach you. You see what happens when you subscribe to my channel? You get an extra greeting at the beginning of every video. So press that subscribe button for an extra greeting. Alright, so we're going to go through section 2.5 on solving quadratic equations using the quadratic formula. And to start, we're going to look at deriving it, so where it comes from. And then we are also going to look at the discriminant, which is a specific portion of the quadratic formula. And then bringing it all together with factoring quadratic formula and completing the square. So these are different methods to solve a quadratic, and we're looking at specifically the quadratic formula today. So to derive it, so we're going to derive the quadratic formula. And to derive it, we're going to start by dividing both sides by a. So if we divide by a, the first term, the a cancels out, so we have x squared plus, and then for the second term, it's going to be b over ax. That's the same thing as bx over a plus c over a equals 0. And make sure you're following along with this because you're going to be doing the first try of this problem based off of the derivation of the quadratic formula. So from here, we're going to follow the same process as completing the square, except instead of having actual numbers plugged in, we're just using variables. So I'm going to bring the c over a over to the other side. So that's negative c over a. And I want to come up with a value here that will allow me to get a perfect square trinomial so that we can get a perfect square here. So as we went over in yesterday's lesson, to come up with that value, we want to use b over 2 squared. And in this case, b is actually b over a. So this is our b value, is b over a. So we're going to take b over a, and we want to do that over 2 squared. So that's the same thing as just going, if you take a fraction, you divide by 2. So b over a, that's the same thing as b over 2a. I don't know what's going on with my handwriting. b over 2a squared, which is b squared over 4a squared. Okay, so it's pretty gross looking, but it's not too bad. We're actually over halfway through it at this point. So that's b squared over 4a squared, b squared over 4a squared. And again, to factor this, so to put it as a perfect square, it's going to be x plus, and then remember when we came up with the factors, we did half of the b term. So half of b over a is b over 2a. So, and you could check that. You could actually FOIL out x plus b over 2a times x plus b over 2a, and you would get x squared plus 2 b over 2a x plus, and then that's b squared over 4a squared, and then the 2's cancel out. So you're left with x squared plus b over a x plus, and then that third term. So from here, on the right side, we have minus c over a plus b squared over 4a squared. And I want to combine these fractions together, which means we need to do a least common denominator. So the least common denominator between a and 4a squared is 4a squared. So I'm going to take negative c and multiply that by 4a so that we can put it over 4a squared. So this is just times 4a times 4a. So I'm multiplying by 4a over 4a. And then from here, I'm going to bring it over here. We've got x plus b over 2a squared equals, and I'm just going to change the order. This is b squared minus, so I'm putting the b squared term first, and then minus 4ac. So I'm just putting them in alphabetical order, and that's all over 4a squared. So from here, just like with completing the square in yesterday's lesson, we're now going to take the square root of both sides. So this is x plus b over 2a equals, and when we take the square root, don't forget that it's plus or minus b squared minus 4ac all over 4a squared. Now from here, we have x equals, and then I'm going to bring the b over 2a, subtract it from both sides, and we're almost to the quadratic formula, but there's one more thing we need to do. You can't have a denominator with the square root in it. You have to rationalize it. So what we can actually do is simplify this denominator. So this is the same thing as, this is right here, the square root of 4a squared, that's 2a. So this is x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over, I'm sorry, not all over, I'm getting excited for the quadratic formula, over 2a. So notice that both of those denominators are the same, so we can actually write this as negative b plus or minus the square root of b squared minus 4ac all over 2a. So all the terms are over 2a. So this right here is the quadratic formula, and you should memorize it. Although you get to use notes and everything on the test, you will need to have it memorized for next year. So might as well get started on that. So again, this is the quadratic formula, and this process that we went through shows where that actually comes from, and you can use this formula to solve for x, to solve for what values make the equation true. So we're going to go ahead and try that out on the first problem. It says use the quadratic formula to solve x squared minus 12x equals negative 20. And notice that a, b, and c were these coefficients. So you're going to be using the coefficients when you solve using the quadratic formula. But before we can go determine what a, b, and c are, we need to make sure that this is in standard form. So I'm going to bring the 20 over to the left side. Add 20 to both sides. So that way it's in standard form. Once you have it in standard form, then you can identify what a, b, and c are. Don't try to identify a, b, and c until after it's in standard form. So a is 1, b is negative 12, and c is 20. So you can take this formula and plug these numbers in. Negative b, so negative 12, plus or minus the square root of, and that's b squared, so negative 12 squared, minus 4 times 1 times 20. And this is all over 2 times a, which is 1. So we're going to simplify. This is positive 12 plus or minus the square root of negative 12 squared is 144 minus 4 times 20, that's 80 all over 2. So 12 plus or minus the square root of, that's 64, so that works out nicely, all over 2. So we get 12 plus or minus square root of 64 is 8 over 2. And then we have two separate answers here. So this is 12 plus 8 over 2, which is 20 over 2, that's 10. And 12 minus 8 over 2, which is 4 over 2, that's 2. So our solutions are x equals 2 and x equals 10. And if you think about those two numbers, so those are going to be numbers that we could have factored this to get those numbers. We also could have completed the square, but this quadratic formula will work for every single problem. So it's not going to always work out to be nice numbers, but it will work. All right, before we do these next couple problems, it says if you get a radical in your solution, so that's a square root. In this last one, we did not get a radical. We were able to get rid of it because we know the square root is 64. But if you get a radical in your solution, then you want to leave it in there. So this makes it what we refer to as an exact solution. And you're not going to be checking your homework with the textbook answers, so you don't need to worry about calculating it to see if you got the right solutions. So don't worry about that part. because you're just going to check the answer key. So, all right. Number 2, it says use the quadratic formula to solve, and then we've got terms on both sides. So first thing we do is put it into standard form. So I'm going to add the 5x, subtract 12. So we know that A is 3, B is 5, and C is negative 12. So take the quadratic formula. X equals, this is negative B, so negative 5 plus or minus the square root of, and that's B squared, so 5 squared minus 4 times A times C. You have to be super careful with your signs when you're doing the quadratic formula. There's a lot of positives and negatives, so make sure you're really careful with that. And also make sure that you show work. So at a minimum, you should have this, and then maybe like this, and then your answers. So at least you're showing plugging the numbers in, and then a step of simplifying, and then your final answers, or show all of your steps so that way you don't make any mistakes. So we have negative b plus or minus all of that, all over 2 times a, and a is 3. So I'm going to start simplifying. This is negative 5 plus or minus the square root of 5 squared, that's 25, plus 4 times 3 is 12, times 12 is 144, all over 6. So we get negative 5 plus or minus the square root of 169 all over 6. And the square root of 169 is 13. So that's negative 5 plus or minus 13 all over 6. So negative 5 plus 13 over 6. And then we're going to do negative 5 minus 13 over 6. So plus or minus, we need to do a problem with adding the 2 together and then subtracting the 13. So 13 minus 5 is 8 over 6. That can be simplified to 4/3. And negative 5 minus 13, that's negative 18 over 6, which is negative 3. So our 2 solutions are negative 3 and 4/3. And I was thinking that this one was going to turn out to be one with a radical in the answer based on the placement of this reminder. However, it was not. So when you do the next one, go ahead and, well, you can pause the video when you're ready to start to try this problem, but make sure that you don't continue once you get the radical in your answer, and once it's simplified as far as you can go. So go ahead and pause it. I'll put a little note for the end on what that looks like. And then, actually, now that I'm thinking about it, we did go over this in the completing the square lesson. So it's the same concept. If you get like negative 4 plus or minus the square root of 3, this can't be simplified, so you leave your answer like this. So your answer would be x equals and then that, which is technically 2 solutions. So we did go over that yesterday. So if your square root can be simplified, make sure you simplify it. Like the square root of 18, that's 9 times 2. You could take out a 3. So make sure you simplify if it's possible, but then you'll leave your answer like that. So it could be like negative 1 plus or minus this quantity all over 2, whatever it is. Okay, and then